All right, so let's try rational functions, and let's see if we can get horizontal asymptotes, aka long-run behavior, and actually maybe get some like full-on graphs here. So first things first, I need some examples. So I'm going to make up some examples. So I want f of x to be x over x squared plus 1. I want g of x to be 3x to the 4th over x squared minus 1. And I want h of x to be 3 times x minus 1 times x plus 2 over 2 times x plus 1 times x minus 2. And I should hopefully be able to get a decent picture for all of these by the time I'm done. So first things first, to get horizontal asymptotes, just think about f of a big number. So really what I'm doing, right, is I'm really taking a limit as x tends to positive infinity. And then I might also think about a limit x tending to negative infinity. Okay, so if I put a really big number in here, I get big over big squared plus 1. Okay, so does adding 1 to big squared probably make a difference?
Not really.
Not really, so we'll just kind of dump that piece. So then I've got big over big squared. That's going to be
1 over big.
That's going to be basically 1 over big.
Which is pretty small.
Which is really small.
Yeah, so the bigger
okay,
you get,
so
the smaller you get.
If I plug in a really big number, right, if I do the limit x tending to infinity to f of x, I get 0 out. Okay, so what that tells me in terms of a picture is this. There's some kind of behavior as I go out towards the end, we're going to tail into 0. I guess I only figured these ones out. If we do this with a negative big number, we'll get 1 over negative big, which will give us 0 anyway, right? Give us negative 0.
Yeah.
Okay, so I've got these two bits, right? And I'm not sure which one it is, because I don't know whether it comes up to 0 from the bottom or down to 0 from the top. Okay, well, I can probably figure it out. So let me put on the other things I know about this. I want to know about asymptotes, right? So when is the bottom on this thing 0?
At I want to say -1, that's just going to create +1, so there isn't a 0.
Yeah, so this is x squared plus 1 is 0, so you subtract 1, you can't square root -1, right. So there's no vertical asymptotes.
Right.
So I don't need any of those. When are there zeros or holes?
When x is 0.
Okay, there's 1 0 and x is 0 and no
0
holes.
1. So that 0 over 1 should be right.
0 over, yeah. 0 over 1, 0. Perfect. Cool. All right, now maybe I want to anchor some more points. So let me just plug a couple points in here. And that's going to let me figure out which way we're going down, right? So I'm just going to go pick your favorite positive number.
2.5. 3 halves.
Cool. So I'm going to get whatever that was divided by whatever that was squared plus 1. So specifically the bottom here is going to be positive. Right? So I'm thinking like plug in whatever here. So I got something over a positive number. Is the top positive or negative?
Positive.
Positive. Positive over positive is positive, so I'm talking about something up here. Okay, so now I know it tails down from above. I know it can't come up from the bottom because I know it doesn't cross again.
Right.
So I know I've got this tailing in on that side, at the very least. Okay, if I do the same thing for the other side, so I pick a negative number here, right? And I've got negative on the top, because I just get that number on the top. And on the bottom, I get something.
It's negative squared, so it'll be positive, so you end up with a negative number.
So I got a positive thing on the bottom. And you might have to be a little more precise with these on other problems, but on this one, it's pretty chill. So I got negative over positive as a negative. Okay, so my dot's down here, which means that I have to tail
down.
You know, my tail's on the downside, so I'm tailing up to 0.
Oh, right.
Okay? Then I have to figure out how to connect the dots here,
Right.
which is actually a little hard. But I know that this goes either like that. Okay. So if you make an X through the zeros, right? On this side I'm up, right?
Mm-hmm.
So I have to come into that 0 from the top.
Mm-hmm.
And now on the other side I have to get to the bottom. So I have to actually go through that in a what's called a transverse intersection, right? It actually slashes through the x-axis instead of just touching and tagging off.
Okay.
Cool. So I got a good picture, actually. It turns out that this is actually a really decent picture of this function. I don't know the heights exactly, but I could ballpark where they are.
Okay.
Cool.
So it starts going down once it starts getting the fractions? Like if you get less than 1 is when it starts heading down?
Yeah, I'm not actually sure where that peak is. Right, I'd have to use a calculus tool to find that thing, or a calculator.
Okay.
But I could maybe guess at it. If I just start plugging in random numbers, I could maybe kind of
Find that
feel
maximum
in.
value. Yeah.
Yeah. All right, so how about G, where I've got 3x to the 4th over x squared minus 1.
So asymptote at 1 when x is 1.
Okay, so yeah, so let's just start sketching things down. I know the bottom's 0 when we're at 1. Is that it?
There's a hole at 0.
Wait, go back.
What?
Where's the other vertical asymptote?
-1.
Okay. Right, we should be setting x squared minus 1 equal to 0.
Right.
So we get 2 asymptotes. Then what else do we know about this thing?
Hole at 0. Because if you plug 0 on both. No, actually, no. We can have
Yeah, so
0 over a number, so it's going to be a regular number. We can do that.
Yeah, so this is, if I plug 0 in, right, I notice the top is 0 when x is 0.
Mm-hmm.
So I get 0, and then the bottom's -1 there.
Right.
Who gives a crap? It's 0 over a number,
Yeah,
so that's
that's
a
fine.
0.
Mm-hmm.
Is the top ever 0 otherwise? Right, so kind of off to the side here.
Maybe.
To find the asymptotes, I set x squared minus 1 equal to 0 and solve.
Mm-hmm.
To find the zeros, I'm setting 3x to the 4th equal to 0 and solving.
Mm-hmm.
So first things I'm going to divide by 3.
Give you x
Then,
to the 4 is 0.
so I'm going to get x to the 4th is 0.
So when x is 0, essentially.
Yeah, and that's the only one.
Yeah.
So I got my 0, and I got my 2 vertical asymptotes. And now what? Well, I need long run edge behavior.
Mm-hmm.
So I might think to myself, okay, so if I plug in a big number, right, I get 3 big to the 4th over big squared minus 1.
Right.
Okay, the minus 1 doesn't really matter, right?
Mm-hmm.
So I'll just pitch that. Then I got big to the 4th over big squared.
Right, which is 3 big squared.
So I'm going to get, yeah, something like 3 big squared. Okay, so this thing's going to look like the parabola 3x squared in the long run.
Mm-hmm.
So 3x squared out here is going to look like this, right? So I'm going to put those arrows there. It doesn't look like that in the middle,
Right.
right? Because I know it's got 2 asymptotes and it goes through 0 somewhere.
Mm-hmm.
But I do know that towards the end it looks like x squared.
Mm-hmm.
Well, 3x squared anyway. Okay, so how do I figure out what else it looks like?
We got to figure out what's going on between those asymptotes.
Yep, so can I get from up here to, maybe let me throw some. So on this asymptote, right,
Mm-hmm.
I know that some of these red arrows have to be obeyed. Right, it's either going towards infinity or minus infinity on each side of the asymptote.
Mm-hmm.
Okay, now, I know it looks like x squared as I move towards the left end of this picture. So I know this arrow's on there. Now, which one of those 2 red arrows can I cross out here?
One on the right, on the top, no, on the bottom.
Okay, so I'm looking at the left side.
Left side, okay. So the top one probably doesn't squeeze back up. Wait, no, it's squared, so it isn't going to go below y.
Okay, so look for the zeros.
Right.
To get from this black arrow that I know has to be there to that red arrow, I have to go through zeros somewhere.
Right.
But this thing doesn't because I already found all the zeros.
Right.
So I know that arrow can't possibly be the case. So it does have to squish back up in there.
Ooh. Okay.
So it looks something like this.
Okay.
And like I've got a piece of a parabola.
Would it get super close to the line until you got to fraction land and then shoot up? Like, would it pretty much get super close to that number?
Oh, yeah, how
1.
close is this?
Yeah.
I don't know. It depends on the calculus.
Okay.
That depends a lot on how much, let me not do that.
Okay.
All right, let's see. So in the middle, I think I'm kind of screwed for a second, so I'm going to leave that alone.
Yeah.
On the other side, I know it goes up, right?
Right.
Like as I go towards positive infinity, it goes up, which means that I can drop out one of these two
The
tails.
bottom one, because there's no zeros. It can't cross.
It can't go down. It has to go back up. So I think it probably looks pretty similar to the other side.
Mhm.
Yeah,
And
in
then-
fact, if I thought about this for a second, I would notice that this function is even.
Mhm.
So it's got to be symmetrical for flips. So these two pieces actually should be exactly the same.
Right.
And actually knowing that, I know that this thing has to either be both up or both down because it's got to be symmetric for flipping. But we can figure that out in other ways. So I would say let's figure that out this way. If I'm over here, right?
Mhm.
So picking right here, I'm kind of thinking about a number, thinking arrow? Weird. I'm thinking about a number that's like a little smaller than 1. Right? So if I plug a number that's not quite 1 in here, I'm going to get a positive number in the top
Mhm.
and a
Negative number in the bottom. Because
negative
you're gonna have
number
a
in the
really
bottom.
small number in the bottom.
So
little squared.
either way, right, it's
Mhm.
positive over negative,
Mhm.
so that's down here.
Mhm. We can do the same thing on the other side.
If I do the exact same thing on the other side, I'm going to get a positive number because it's something to the fourth,
Right.
divided by, and again, I'm not going to quite make 1, so I'm going to get another negative number over there.
Mhm.
And so I know that this thing has to look like a U shape going down.
Oh, that's weird.
Cool?
Yeah. Very cool.
Okay. All right, one more. I'm going to give myself a little more space with that one. Okay, so on that guy, what do we want to do first?
Let's find the asymptotes.
Okay, cool. All right, so the asymptotes are where the bottom's
Or 0.
0 and the top isn't, right?
Right.
So first I should factor and look for onesies. You got any onesies in there?
No.
No? Okay, well, what the heck. All right, so where are the zeros on the bottom?
Positive 2 and negative 1.
Okay, so we're going positive 2, we've got an asymptote. Negative 1, we've got an asymptote. Okay. What else do I know?
We know that there is going to be zeros at positive 1
Okay, there's a 0 at positive 1
and at negative 2.
and a 0 at negative 2.
I'm seeing a tangent line. I'm
Let's see.
seeing tangent, like the graph of tangent.
Oh, one of those things?
Yeah.
Yeah, it could be. All right, so let's see. Then what do I want? What else do I want? I want the long run, right?
Right.
Okay, so if I think about this thing with h of big, right?
Mm-hmm.
So I'm going to get 3 big minus 1 times big plus 2 over 2 big plus 1 big minus 2. Okay, so what?
3 big squared.
Yeah, perfect. So swipe the subtraction or addition, right? Those don't matter
Those aren't
at
gonna matter.
all.
It's going to be big squared over big squared.
So I've got, so I got 3 over 2 big squared,
And some change.
big squared.
Yeah.
So big squared over big squared is
1. So we have a line.
1. So we have just 3 over 2,
Right.
right, which is a number.
Yeah.
So you need to go,
Oh.
right, so my units are like 1 and 2, right?
Mm-hmm.
So 3 halves is halfway.
Mm-hmm.
And so there's a horizontal asymptote there. So I know that there's tail, maybe let me draw my picture in blue or something now. So I know that there's, blue marker's black. So I touched the black thing. Okay, so we have tails on the horizontal asymptote, like this.
Mm-hmm.
We have tails on the vertical asymptotes. So I'm just kind of writing in all the possible tails, and then I'll smack the ones that I can demonstrate aren't possible. And keep in mind, you can cross the horizontal asymptote in the middle here. You just can't cross it up towards the edges. And actually, that's a little bit of a lie too, but whatever. So let's see. All right, what do I need to anchor? Or what do I have that I know I can use? Oh,
It's an even function.
I know I have one thing that I can already use. Don't get attached to the idea this is even, that's not.
Oh. Shit.
If you multiply it out, right?
Mm-hmm.
So you're gonna get like 3x squared over 2x squared for your leading terms, right?
Mm-hmm.
These guys are even, but that next term's not 0, which means that you've got like even and odd stuff mixed up.
Right.
You won't be able to deal with it.
Okay.
I do know something though. I know that this goes through -2 here, right? So if it's gonna go, maybe I don't know that. Damn it, without any calculus, this is hard. Okay, so without any calculus, let's just start cramming numbers that are going to tell us things.
Okay.
So I'm going to think to myself, okay, that asymptotes are probably the easiest thing to grab. So I'm going to ditch this. And I'm going to think about, in red, a number a little bigger than 2. A tiny bit more than 2. I'll call it x hat. Okay, so then I'm going to do h of x hat. So I'm going to have a 3 over 2. That's not going to change. And then all I want to do is figure out the signs of all these things. So x minus 1, if I'm a tiny bit more than 2, is positive or negative?
Positive.
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 A tiny bit more than 2 is plus 2 is a tiny bit more than 4, so I got a positive,
Positive.
positive,
Positive.
and positive.
Barely.
Okay, so I got something, 3 halves times something positive. I don't know how big this thing is, but I do know it's positive. So I know that that dot is going up here someplace or someplace up here. Right? So I know that this tail, this bottom tail, not allowed.
Because of that, do we know that then it's not going to be in that bottom right section? Can we just scratch that whole section off because it
This
can't
whole
come
deal.
from anywhere? Like, where's it going to come from? It can't just magically pop into something. It has to come from the top of an asymptote
Yeah,
or the
so
other side of one.
I'm not totally sure what whether it could do this or whether it's doing that.
Okay.
That makes sense?
Yeah.
That's actually really, really hard to figure out with the tools we have. I'm probably not going to get a good grasp on that, except by picking a really, really big number and trying to figure out if it's bigger than 3/2 or smaller.
Right. Why can it cross the horizontal asymptote?
Because there's nothing stopping it, basically.
Okay.
So the only thing that's going to stop it is when I get to calculus land, I'll be able to find these little turnarounds.
Mm-hmm.
And if I can find the turnarounds, I know this doesn't have a turnaround and that one does.
Okay.
Right now I'm not sure. And it's actually kind of hard to tell. You can cheat a little bit, but you have to know some calculus to cheat. So I'm not going to show you how to do that. So basically, I know this arrow is right, but I'm not sure which behavior it is. It's probably the top one, because these little turnarounds cost something and you can't get that many of them. It's not to say for sure that it's not. But. All right, so let's do the same thing for a number a tiny bit smaller than 2.
Good. So you got positive, negative, positive.
Wait.
Positive?
Tiny bit smaller than 2.
Right.
Positive, positive.
Negative. No. Tiny bit smaller than 2?
Yeah.
Oh yeah, positive. Yeah, it's close. Positive, negative.
Okay, so the only one that's going to switch is the one that actually changes sign at 2, right? So I'm going to get a negative, which means I'm
Down here somewhere.
down on that tail, which means I can't be up on this one.
Right.
Okay, then we do the same thing with -1. So I want a number a little bigger than -1.
We're gonna have -1 minus 1 plus -1, so it's gonna be a negative.
Yeah, and actually I could notice that that's not going to change anything from the last one, because I haven't crossed where any of these guys change sign. I
Right,
really
okay.
am still in that same space. So that's going to be a negative on that guy, which means I got this arrow,
Cool.
which means,
Whoa, so it crosses 1, so it probably just touches it.
yep, so I probably just tag 1 and go back down,
Yeah.
assuming I did my sign test correctly.
Hopefully.
That makes me a little, sorry, did I do my sign test correctly? So a number a little bit bigger than -1 is negative something minus something is,
It's a negative.
oh, shit.
Yeah.
I did switch. I switched this one too.
Right.
So this is not going down. This is going up. It's like an idiot. That makes me feel way better. So I got something like this.
Okay, just crosses.
So the reason that makes me feel better, right, is that these things should be pretty symmetrical. Meaning that if that tag happens, it should be in the middle of the space where it happens most
Right,
of the
and it
time.
wasn't.
And it definitely wasn't, which made me feel a little funny about it. Now this little whoop-de bit that's going on here, I've drawn it like it happens at 1, but it actually happens in the middle of this -1 to 2, probably. Like all things being equal, these should be pretty symmetrical. Let's see, so if we switch sign again, we'll definitely end up with the minus tail here. And again, I'm not really sure on the asymptote. I think it probably looks like this one, and not like the one that goes up and then comes back down. And I'm going to go with that guess over here, but it should be noted that those two are guesses. Those two I don't really have a good tool for. We could plug in some points to get a better idea. Right, like if we went out to 10 million and plugged it in and actually calculated, we'd get something.
We could
else.
find out if it's on top or on the bottom.
Yeah. My guess is that I'm probably right on both of these, but I'm not totally sure of that.
So then, no, it's silly. Yeah, if there's a horizontal asymptote and they can cross, what stops it from oscillating or like doing whatever it wants around
Cool.
the horizontal asymptote?
So that's
why does it matter?
That's that thing about it costs something. So it is possible to have a horizontal asymptote where this behavior happens.
Right.
Right. This is like a spring.
Or if you zoom
Right?
in
When
on sign as it
you've
reaches
got a
0.
spring and you smack it, right? It'll oscillate.
Mhm.
Well, if it's in a frictive environment, the energy in the spring will slowly drain out just due to heat, right?
Right.
The spring gets a tiny little bit warmer, and that's this behavior,
Okay.
oscillating with kind of slowing down. And actually, if you do this, you'll notice that this is a sine curve smashed in between two exponential curves.
That's cool.
Yeah, so things that look like that are e to the x sine x, give or take some constants in there.
Mhm.
And that's really what springs most of the time do.
Cool.
So these things come out of complex numbers in certain differential equations, but whatever. In fact, you guys could see this is a little bit of Euler's.
Right. Yeah.
So there's nothing stopping them from doing that, but polynomials don't have enough juice, basically. There's a calculus thing that'll tell you how many roots you can get out of a rational function. You do the quotient rule, you'll get some count on top and bottom, right? And polynomials can only have that many zeros. They can't have any more, and the zeros tell you about the turnarounds. This thing has infinite many zeros, so it can't be a polynomial.
Cool.
So you can kind of chase that down. The other thing that I want here is just okay, if you zoom way the heck out, right? On this guy, you're going to look like the function 3/2, right? If you zoom way, way out, you're only going to see those horizontal asymptotes and these couple of vertical strikes. On that other function that we did before where we had 3x to the 4th over something, that was if you step all the way out, you'll see 3x squared.
Right.
So those are kind of useful tricks to know. Anything else?